Hello everyone, once again welcome back to Civil Learning Online YouTube channel. As we were learning Laplace transformation, this is second lecture on Laplace transformation. In the previous lecture, I have discussed about some simple formulas and also got to learn how those formulas are applied in while solving numerical, and those numericals could be asked in 2 marks in your examination. So in the previous lecture we have learned some basic formula like Laplace transformation of 1, which is 1 by s. Laplace transformation of e to the power minus at is 1 by s plus a, and some trigonometric formulas and hyperbolic. Now in this lecture what we will do, let me show you. So in the previous lecture we got to learn how to solve the numerical problem of this type, and this type. Now for these 4 types of problem we are going to learn in this video, and we will learn I will provide you with some additional formula which will help you to solve the numerical problem of this type, like when the trigonometric function carries power and when the trigonometric function are in product form. So let's learn without any further delay. Let's get started. So the problem could be find in the form of, while solving the Laplace transformation, the problem could be a form sine a plus b plus sine a minus b equals to 2 sine a times cos b. Similarly, sine a plus b minus sine a minus b equals to 2 cos a into sine b. Similarly, cos a plus b plus cos a minus b equals to 2 cos a times cos b. Similarly, cos a minus b minus cos a plus b equals to 2 sine a times sine b. Also, sine c plus sine d equals to 2 sine c plus d by 2 times cos c minus d upon 2. Similarly, sine c minus sine d equals to 2 cos c plus d by 2 times sine c minus d by 2. Similarly, cos c plus cos d equals to 2 cos c plus d by 2 times cos c plus cos d equals to cos c plus d by 2 times cos c minus d by 2, and cos c minus cos d equals to minus 2 sine c plus d by 2 times sine c minus d by 2. Now let's learn how to remember this formula. So first of all, you need to read it twice, thrice, 10 times. After reading, what you should do, you should try to write the formula on a clean paper, means there is nothing written, and you should try to recall the formula and then try to write on that paper, you will, if you will repeat this 3 to 4 times, then you would be able to remember all those formula. And remember guys, this formula is very important to solve long type questions from of Laplace transformation. So I have provided you here in this video, and here how to remember. See here, there is, you will find similarities between the formula, like sin a plus b plus sin a minus b equals to 2 sin a times cos b. Here it is positive, and when we change the sign, when it comes negative, then cos becomes cos a. Here in the, when it is plus, that is cos b, and here it is, when it is minus, it becomes cos a. Similarly, when it is cos a plus b plus cos a minus b, then it will get 2 cos a times cos b. Similarly, when it is in minus, means this cos a plus b becomes minus, then we will have sin 2 sin a times. Okay, see here, this the similar type of math trick you will find also here in this formula also. Here when we have cos c plus sin c plus sin d, it is actually sin d. Sin c plus sin d is 2 sin c plus d by 2 times cos c minus d by 2. Similarly, when it get minus, then cos becomes cos c plus cos c plus d by 2. Similarly, when it is cos c plus cos d, then it will get cos c plus d by 2 times cos c minus d by 2 times 2. Similarly, when it get minus, then both will become sine, and negative sign we will bring it front. Now you need to learn 4 more important formula, that is cos 2a equals to 2 cos square a minus 1, and from here we can derive formula for the cos square a. So how we can do this? See here, cos 2 cos square a equals to 1 plus cos 2a. What I did here, it is in minus, here my 1 is in minus 1, so I brought it this side, so we can rewrite it as 2 cos square a equals to 1 plus cos 2a. Now we have cos square a equals to 1 plus cos 2a upon 2. Similarly, we have one more formula for cos 2a in the form of sine. So cos 2a equals to 1 minus 2 sine square a. So in the form of sine, if the problem is about sine square a, then we can rewrite it as 2 sine square a equals to 1 minus cos 2a. So sine square a equals to 1 minus cos 2a upon 2. This is also one additional formula, and this is also one additional formula. Now formula for sin 3a. So sin 3a equals to 3 sin a minus 4 sin qa. And if you face any problem in which the sign is in cube form, then how we can solve this? See here, we need to bring this, you need to remember this formula. This formula is very important. This formula is important, and this formula is important. This formula is important. If you remember these 3 formula, and I will provide one more, then you will easily be able to derive if it is required for cos square a, whether it is sin square a, does not matter, and whether it is sin qa, you will be able to derive it by yourself. So remember this formula, sin a minus sin 3a. So from here we can derive for sin qa equals to 3 sin a minus sin 3a upon 4. One more formula for cos 3a. So we have cos 3a equals to 4 cos qa minus 3 cos a. So from here, for cos qa we can derive it as 4 cos qa equals to cos 3a plus 3 cos a. I have done nothing, just I have brought this negative term this side, so it will get positive, and 4 cos qa equals to 3 cos a plus 3 cos 3a plus 3 cos a. So from here we will have cos qa equals to cos 3a plus 3 cos a divided by 4, and these four formula are also important. You need to remember this formula, and this four formula, and this is much for Laplace transformation. Now let's continue our lecture for solution of the numerical problems which I have shown you at the beginning of this video. So let me write down the question, and the question is, we have learned to the solution up to this problem. So I am going to show you for the solution of sine square 3t. So before beginning the solution of this problem, what I would like to tell you is, whenever we face any problem of trigonometric function, so what we need to do is, when we face trigonometric function, it must not be in power, and it must not be in product form. So how, in that case, what we need to do is, we have to convert the power into, we have to remove the power, and for removing the power we will require this formula which I taught you recently. Just this formula will help us to remove the power. So see here how we will solve this numerical. We have sine square 3t. So write down here solution Laplace transformation of sine square 3t. And I told you that Laplace trigonometric function should not be in power or neither in product form. Okay, so what we will do, we will use the formula to remove the power. So we have the formula, that is here sine square a equals to 1 minus cos 2a upon 2. What is the formula for sine square a equals to 1 minus cos 2a upon 2? This is the formula. So I am going to use just equate the both the formulas. So for sine square 3t we will have 1 minus cos, in place of a we have 3t, so 2 times 3 6 t upon 2. This is our formula for converting sine square 3t for removing the power. So we will have here Laplace transformation sine square 3t is equals to Laplace transformation of this is 2 constant, so we will bring it outside. So 1 upon 2 Laplace transformation of 1 minus cos 6t. Now we can rewrite it as 1 upon 2 Laplace transformation of 1 minus Laplace transformation of cos 6t, and put the bracket here. So we will have here Laplace transformation of 1 is 1 upon s, so we will have here 1 upon 2s minus Laplace transformation of cos 6t. The Laplace transformation of cos 6t is going to be s upon s square plus a square, so we will have here s upon s square plus a square is a, in place of a we have 6 here, in place of a we have 6 here, so a 6 square is 36, and we need to multiply this by 1 by 2. You can leave it up to here also, or you can proceed one more step like 1 upon 2, and we need, if we take 1 upon 2, then we will have here inside 1 upon s minus s upon s square plus 36. You can leave it up to here also, or you can proceed further also, it is up to you. So 1 upon 2. Now take the LCM of this lower term, so we will have here s times s square plus 36, and here we will have on dividing this by s, we will have here s square plus 36. I hope you know the fractional addition. I am doing nothing, just the fractional addition. So taking LCM of these two terms, we will have here s times s square plus 36. Now divide this by s, and we will get s square plus 36. So the remaining portion is written in the numerator and multiplied with the number which is in the numerator position, and minus we will multiply this s with dividing this whole by this, so we will get s. So s, now we will have here 1 upon 2 times s square plus 36 minus s square upon s times s square plus 36. Now subtracting, we will get 1 upon 2 times 36 upon s times s square plus 36. Now you can divide this 36 by 2, we will get 18. So our final answer is going to be 18 by s times s square plus 36. This is for this numerical. Now we will see another numerical, that is question number 2. This is question number 1. Sine hyperbolic q 2t. Write down solution, proceed. So as you know that whenever we come to face the trigonometric function, then we should check for the power as well as the product of the trigonometric function. As you can see here, it is in here the sine hyperbolic 2t has power 3. It means we have to we have to remove the power from here. So in order to remove the power, we have to use the formula. See here we have formula in the form of cube, that is sine cube a equals to 3 sine a minus sine 3a upon 4. So here cube hyperbolic cube 2t is going to be, let me show you, we have sine cube a equals to 3 sine a minus sine 3a upon 4. Now on equating these two equations or the term, what we will have here, sine hyperbolic cube 2t will be equals to 3 sine hyperbolic, in place of a we have 2t, so we will place here 2t minus sine 3t, 3a means sine hyperbolic, in place of 3 and a in place of a we have 2t, so 2 times 3 is going to be 6t and divide by 4. So Laplace transformation of sine hyperbolic cube 2t is equal to Laplace transformation of 1 by 4 Laplace transformation of 3 sine hyperbolic 2t minus sine hyperbolic 6t. Now what we can do here, 1 upon 4 times 3, and sine hyperbolic 80 formula is a means 2 upon hyperbolic means s square minus a square minus sine hyperbolic 60, again a upon s square minus a square means 36. So this is what we will have here. Just put this bracket for 1 multiplying by 1 by 4. Now see here guys, in these two terms, in this term and this term, 6 is common because 3 when multiplied by 2 we will get 6. We can take 6 common, so here we will have 6 upon 4 times 1 by s square minus 4 minus 1 by s square minus 36. So on taking LCM, what we will have here, 6 upon 4 is actually 3 times 2 times 3 by 2. Now take the LCM of s square minus 4 and s square minus 36. So we will have here s square minus 4 times s square minus 36 times s square minus 36 minus s square plus 4. How this came I am going to explain now. So here what I did the fractional subtraction. So on taking LCM of s square minus 4 and s square minus 36, its LCM is going to be s square minus 4 times s square minus 36. So what I did, I divide this term by this s square minus 4. What we got, remaining term was s square minus 36. On dividing these two by this, we will get s square minus 36. I wrote it here, and this minus sign is here, and due to this minus sign, what will happen, we are doing here is multiplying this one by this term, and here also we are multiplying this one by s square plus 4. And why s square plus 4? Because we divide these by s square plus 36, remaining is s square plus 4, and remaining is multiplied with numerator, and numerator is 1 here, so we have multiplied s square plus 4 with 1. Now this minus sign changes the sign here, s square minus 4 on multiplying this will get converted. Actually this is here 3 by 2 times s square minus 36, and due to this sign the s square will get negative, and it was minus 4, so it will get plus 4 upon s square minus 4 times s square minus 36. So on solving this, we will get 3 by 2 times minus 36 plus 4 will get minus 32 upon s square minus 4 times s square minus 36, and 2 on dividing 32, we will get 16 times 3 is minus 48 upon s square minus 4 and s square minus 36. This is our final answer. Now we will look for some additional example which I have shown you initially in this video, and our next question is going to be, so our next question is cos 3t times cos 2t. Again here we have encountered with trigonometric term, and trigonometric term are in product, so we need to remove this product sign. And how we can do this? We need to use the formula here. See here, we are going to use this formula. It is in the form of cos A times cos B, 2 cos A times cos B. So what we will do here, see here, it can be written as 1 by 2 times Laplace transformation of 2 times 2 cos 3t into cos 2t. Why I have multiplied and divided it with 2? Because it was not in the formula form, 2 was missing here. If we are going to use the formula, then it must be in the form of 2 cos A into cos B. Here 2 was absent. What I did, I multiplied and divided by 2 so that we can use the formula. Now we will use the formula. 2 times cos A into cos B equals to, so 2 times cos A into cos B equals to cos A plus B means 3t plus 2t is 5t, cos A plus B plus cos A minus B means 3t minus 2t is cos t, and Laplace transformation of this, and 1 by 2. So here, from here we can have 1 by 2 times Laplace transformation of cos 5t plus multiply this both terms by 1 by 2, 1 by 2 Laplace transformation of cos t. Now use the formula. Now it is in the form of cos at, so we will have here 1 upon 2 times cos at means s by s square plus a square minus 1 by 2 times, sorry this is plus, so plus 1 by 2 times s upon s square plus a, in place of a we have 1 here, so 1. Now we need to take the LCM and do the further calculation. So take 1 by 2 common from both the terms, so we will have this, and on taking LCM of s square plus 25 and s square plus 1, we will have LCM is going to be s square plus 25 times s square plus 1. Now what we will do, we have numerator as s, so s is going to be multiplied with the remaining terms, so divide s square plus 25 times s square plus 1 by s square plus 25, remaining will be s square plus 1, okay, plus again we have s here, so s times is going to be s square plus 1 get cancelled out, so we will have here s square plus 25. it would have been better if we would have taken s common, then it were numerator were only 1, would remain only 1. So let's take s as common. So on taking s common, we will have here s square plus 1 plus s square plus 25. So we will have here s upon 2 times s square, 2 s square plus 1 plus s square plus 25 means 2s square plus 25 plus 1 is going to be 26 by s square plus 25 times s square plus 1. Again, from these two terms we can take 2 common, so we will have here 3 upon 2 times s square plus 13, because 26 is 2 times 13, so it can be written as 2 times 13. So we can take 2 common from both the terms. So that is what I did here, 2 times and s square plus 25 times s square plus 1. So 2 get cancelled out, so we will have here 3 times s square plus 13 upon s square plus 25 times s square plus 1. Okay, now we will solve new numerical problem, that is for question number 4, and that is different from what we have been doing till now. So again we have here sine 80 times sine hyperbolic 80. I am going to write it down here, sine 80 times sine hyperbolic 80. Now time to provide you 3 more formulas for hyperbolic function, and it is in the form of product. So here we use this formula 2 times cos A into cos B times formula, because they were like term, but here it is different. Here it is not hyperbolic and here it is hyperbolic, means it is 2 different terminologies. So there is different formula for sine hyperbolic theta, and that is, so we have 3 more formula for sine hyperbolic theta, cos hyperbolic theta and tan hyperbolic theta, and that is sine hyperbolic x equals to e to the power x minus e to the power minus x upon 2. These are simple easy formulas. And similarly for cos hyperbolic x, we have e to the power x plus e to the power minus x upon 2, and tan hyperbolic x equals to, simply divide these two, because tan theta equals to sine by sine theta by cos theta. So e to the power x minus e to the power minus x upon e to the power x plus e to the power minus x. Now you have come to know what we are going to do here. See here we have sine 80, so Laplace transformation of sine 80 times sine hyperbolic 80 will be equals to Laplace transformation of sine 80 times sine hyperbolic 80. Sine hyperbolic 80 means e to the power x minus e to the power minus x upon 2. So we are going to use this formula here, 1 upon 2 times e to the power 80, because in place of x here, in place of x we have 80 here, in place of sine hyperbolic x, in place of x we have 80. So e to the power 80 minus e to the power minus 80 upon 2. It was from formulas. Actually this is product sine hyperbolic 80 equals to e to the power 80 minus e to the power minus 80 upon 2. So what I am going to do here, I am going to multiply this 2 with sine 80. So we will have here 1 upon 2 Laplace transformation of sine 80 times e to the power 80 minus 1 upon 2 times Laplace transformation of sine 80 times e to the power minus 80. So now Laplace transformation of sine 80 times e to the power minus 80. This is very simple, just watch it. What I am going to do here, I am going to rewrite it as it is 1 by 2, and we have sine 80 formula. Sine 80 formula is a upon s square plus a square. You know remember this formula. So in play what due to this exponential 80, what I am going to do here, we have to add, we have to just bring some changes in this formula here, that is s, and it is in a is positive, so we will write here s minus a. That's it. See once again, 1 by 2 upon, we remember sin 80 formula is a upon s square plus a square, and a is here, due to this exponential we have to add with this s, we have to make some addition to this s term. So we have minus 80 means we need to write plus a square. Now take a common from both, a by 2 common from both, so we will have here a upon 2 times 1 upon s minus a whole square plus a square minus 1 upon s plus a whole square plus a square. Now we need to do few calculations here. See here, we need to take the LCM of both the terms. What will be the LCM? Let me show you here. We have first term is s minus a square plus a square, so it is going to be s square minus 2as plus a square plus a square. We can rewrite it as s square plus 2a square minus 2as. Similarly, we have one more term, that is s plus a whole square plus a square, so we will have here s square plus 2as plus a square plus a square. Again we can rewrite it as s square plus 2a square plus 2as. Means, like, see here, if we consider this term as a and this as b and this as a and this as b, we have it is in the form of this. First expression is actually a minus b and second one is a plus b. So on taking LCM, we know the formula that a minus b times a plus b is equal to a square minus b square. So we can rewrite it as the a square minus b square. So what it will be, see here, from this s minus a square plus a square we got this a minus b, and from s square plus a square we got this a plus b. So on doing the product we will have to make it a square minus b square. So our a is s square plus 2a square whole square minus b square means 2as whole square. We will have here s to the power 4 plus 2 times s square, this is a and this is b, so 2ab, a plus b whole square formula is a square plus 2ab plus b square, so 2s square times 2a square, okay, plus 2a square whole square, which is 2a square whole square is going to be 4a to the power 4. So I will do that in next step. So and 2as square means 4a square s square, and from here you can see that 4 2 times 2 4 a square s square gets cancelled out. So we will have here s to the power 4 plus 4 a to the power 4. So from here we are going to have a upon 2 and these two gets converted into the form s to the power 4 plus 4 a to the power 4. This is similar to, this is same as this. While doing LCM we will have, on taking LCM of these two we will have these two terms here. So what I have done, I have just combined these two. On combination these two will get converted into this, which I have shown you how this gets converted. So on dividing this term by s minus a square plus a square, we will get here s plus a square plus a square 1 times this numerator is 1 here minus this 1 times s, this positive 1 gets cancelled out, so we will have here s minus a square plus a square. Okay, so now we will need to do some calculations, that is s plus a square is s square plus 2as plus a square plus a square minus, will change the sign here. I am directly going to change the sign, so s square plus 2as plus a square, sorry, it will be minus a square because s minus a square is plus s square minus 2s plus a square. Minus 2s gets positive and plus a square gets negative, and plus a square, and this whole gets divided by s to the power 4 plus 4a to the power 4. Now cancel out the opposite signs, so these two gets cancelled out and s square gets cancelled out. So we will have here a upon 2 times 4 a yes 4a yes plus 2a square upon s to the power 4 plus 4a to the power 4, 4as plus 2a square. 2 we can take 2 common here, so we will have here 2a times 2s plus a upon s to the power 4 plus 4a to the power 4. 2 and 2 gets cancelled out, so we will have here a square times 2a 2s plus a upon s to the power 4 plus 4a to the power 4, and this is our final answer. I hope you understood this numerical, and see you in the next video. Till then, stay safe and take care of yourself, and in the next lecture we will learn some new examples with new formulas. See you there.